field of information management at Nanyang Technological University, and he also displays interest in usability design, cognitive computing, cricket, photography, and teaching children as well. So I'd like to invite you to start the session.
Okay, thank you. Thanks for the introduction, and thank you all for making it. So I think I will take the next 1 hour or so to share some of my experience. I come from the industry, and you of course are studying some of these subjects and you are trialing it, so your brains are fresh and you will have even greater ideas. So the idea behind this session is share the industry point of view and also learn from you what you guys are doing, and based on that maybe we can strike some collaborations going forward. Maybe you've got some ideas and so on. And as we all know, artificial intelligence is not something that is new. It has evolved over the time, and it's been around for more than 60 years, to be honest. So the term AI was coined about 60 years ago, so there's nothing new about it. But somehow things have come together in the recent times. And I'm also here actually for a specific reason. That is because of this foundation called OpenPOWER Foundation. So I of course work for IBM, and IBM is one of the founding members of this particular foundation called OpenPOWER Foundation. And what we decided was that technology is being opened up greatly. There are a lot of open source and open technology initiatives happening in the recent times, and we thought maybe we should bring some partners together and work with them in their own areas of expertise, and as a result of that, these culminating together will result in better technologies. So that was the whole idea behind this. So we partnered with companies like Google, Micron, of course in the chip industry, NVIDIA, of course, you know, if you are into gaming, you know who they are, and Red Hat and Ubuntu, of course, you know, the Unix partner. So the rest of them are familiar names to you too, like Hitachi and Mellanox and so on, and you might have also heard of Samsung and so on. So these are all mobile world, and you will have mobile phones from some of these vendors too. So we formed this consortium, which is called the OpenPOWER Foundation, centered around some of our chip technologies in order to enhance and collaborate together to bring in best in the technology. And in today's talk, I will cover about 4 different aspects in the next 45 to 50 minutes or so. I'll first introduce to you the world of digital intelligence, and then we'll move on to some of the challenges and how we are mapping these challenges to some of the use cases and getting back with some of the interesting deployments in industry. Then also we'll talk about some of the technologies specific to IBM and how you can get started today, because at the end of the day you're learning something, you want to put that into practice, and how you can get started today. Now through all this section I want you to think and innovate and come out with some creative ideas, because bulk of my presentation is going to be around some of the theories that have been put into practice, and some of the customers who have already starting to either pilot or already starting to use some of these technologies. So maybe you'll have some interesting ideas to solve problems around you. You don't have to go that far. Solve problems around you in simple, interesting, creative ways without, if I may use the word, complaining. You know, we are all good at complaining. And I've lived in Singapore for nearly 6-7 years, and the Singaporeans there think they are best at complaining. And I tell them, as human beings, we are all complaining, because the moment you kind of used to something and the advantages of it, then you say, okay, I want something better. I want something even better. I can't wait for this bus. I want it much faster. So maybe we can think through and find something interesting to come through. Okay, this is moving really fast. I don't know why. Something didn't work right. So let me just go back. think there is some problem with the connectivity. Okay, let me see. Will help. Okay, now it's good. So, as human beings, there are certain things that we are really, really good at. That is, we can understand, we can reason, and we can learn things. And that is what we have been doing from our childhood days. I hope you will remember your beginning days where your mom or dad called you and showed you what a cat looks like, what a dog looks like, and then you will look at a cat and say it's a dog, and then you look at a dog and it say it's a cat, and then your parents will correct, and you will start to learn fast. And do you know that when you're a child, you take pictures in your brain at speeds phenomenally, and by the time you're like 3 years old, you have mentally and using your brains, you have taken millions of pictures. And that is your beginning, and you learn very, very fast. And human beings, we are good at understanding, reasoning, and learning. But the challenge is also we forget as we grow older. You're still young, but we forget, and you get tired, and we are not fast enough to keep up with the pace. And that is where there is this new phenomenon called artificial intelligence that is coming forward, where intelligence is artificially created and infused into various technologies so that you don't forget, you don't get tired, and you're fast, you're quickly doing stuff. And as a result of that, there are these terms that have come into play, like deep learning, machine learning, artificial intelligence. These terms are interchangeably used in the industry and in the academy, but there are specific definitions around it, and coming from the university, I think you'll be very particular about how to define something and how to go by it. I have borrowed these ideas, and I've just put it from the theory books, saying what deep learning is all about, what machine learning is all about, and what artificial intelligence is all about. So let me explain to you with some use cases and some examples for those who are not into that field particularly, because I sense that you are from different backgrounds, so it's always good to cover some basics. So artificial intelligence is about mimicking human beings. So one of the examples is self-driving cars. It's a complex procedure, because as you learn driving, you will understand what are the things you got to do. You got to know the difference between a stone and a small little paper bag that is around, which may look sometimes alike. You got to know the difference. And how did you do that? Because you have learned it in the past. And then there is machine learning, is learning with experience. So just to give you an example of what it is like, in the days when emails came by, there was this concept of spam mails coming. Now you don't really look into it, but on and off you look into it. But in the beginning days, you looked at this a lot, spam. So the computer over a time period learns through experience and learns to understand how a spam mail would look like, and that is because you have assisted. And similarly, if you are inputting a search in Google and you type something, and maybe sometimes you make a typo error, and the computer would come back and ask you, did you mean this? And it automatically corrects. And over a time period, when you press the backspace and retype something, the computer has learned and it has memorized it, and as a result of that, it has become. So these are some examples of machine learning. Now deep learning is more like self-learning with more data, so it's more higher area of action. Now all this actually require a lot of data, and the world is exploding with a lot of data, and training of these systems requires a lot of data to be input inside. Now there are so many use cases around the world that is emerging to inject artificial intelligence, and they are in various fields, starting from in home. I saw there is a Wi-Fi plug now that is commercialized, where I can control a device in Sri Lanka from Singapore by scheduling it and so on over the internet, and that is consumer and it's available for you to buy. Then there is energy consumption, medicals, computing, mobility, electricity management, and so on and so forth, robotics, and you can, from the icons you can see. So all these fields are now beginning to adopt and embrace artificial intelligence in some way or the other. It may not be that prominent in Sri Lanka, but at least when you watch TV and you see news, you can kind of get an understanding of how things are emerging. Otherwise, maybe you're reading something in the news or maybe you're studying something. And this will all give you a sense of how things are evolving in the recent time. And the smart people, the academics and those who are in the research area, what they're saying is that we are just beginning this journey. It is the beginning of something very unique. So which means it's another new wave of things that are coming. Over the years you would have seen, like the computer came, then the computer became a mobile computer, a laptop, which is now available with most of you. Then the phone came. I still remember the first cell phone that I saw was this big. It was from, I think, Celtel or something, and I was working for IBM in Sri Lanka at that time. And I remember one of our colleagues, and one of my colleagues just walked in also, Ravi. So I remember those days. If you remember, Shiran used to have a Celtel phone which was like this big. Yeah, it was so big, and things have evolved over a time. And then cloud computing came, and that has evolved, and you're using cloud computing on a daily basis, but you're not aware of it. Whether you're using emails, whether you're using Google Drive, whether you're using Dropbox, and so on and so forth, you're using cloud computing in some ways to at least store data. And artificial intelligence is already injected into some of the things you are using nowadays. For example, how many of you are photographers? Into photography or hobby at least? I'm sure you're taking photographs somehow because you have got a mobile phone, right? Now, if you upload it to websites like Google and so on, they will be able to now understand what you have taken in the picture. It could be like blue skies, sea, buildings, colors, and so on. You don't have to tag those images. They are automatically identified. So artificial intelligence is beginning, and it's everywhere. But what, from an industry point of view, let me tell, these four aspects are actually required, or this is what customers are looking at, this is what industry players are looking at. One is the right idea. Second one is the right way of collaborating and making sure that the systems work well. And thirdly, it's the right price. Everybody is price sensitive and price concerned. And fourthly, it's the right connections to make for you to actually productize something. And I'm sure when you have some ideas and you want to make it big, you have to consider all these factors. Anybody into startups and beginning new ideas, you want to start a company, or at least you have the interest to do that? Anyone into that type of areas? Okay, there you go. So there are quite a few actually who have interest in starting something new with your own ideas. So you will have to consider all these aspects. Now, artificial intelligence is also taken another twist, and a lot of people are thinking different ways, and they're thinking, oh, okay, so I don't have to depend on human beings to do certain things. For example, let's say security monitoring. Now, typical traditional way is that you would have cameras all over the place, and then you will have computer screens in like a central control monitoring area, monitoring facility, and then somebody is sitting and monitoring things and looking for abnormalities. Let's say, for example, non-smoking zone. Let's say, for example, high security zone. So you're monitoring and making sure that things don't fall apart or security is not breached, isn't it? That is the traditional way. But now there are ways and means that are coming up. You don't have to have a human being monitoring through all the screens, but rather intelligently the devices themselves are able to spot these objects, and they're able to tell what the issues are. So those who are doing the job of monitoring the screens and all that, there is a good chance they may lose the job in future, in days to come. So there is this argument about, is AI going to create more problems? Now that is a big worry that some of the academic and also in the industry they are telling. So my view is that, this is my personal view, there is every technology that you can use it for your advantage as well as for your disadvantage. I take a typical case of motor cars. When motor cars were invented, what was the purpose? For you to go from one place to the other more efficiently, much quicker. But now motor cars are used for even for killing people, isn't it? So did someone ever think that motor cars would be used to kill people? Like you drive in the opposite direction of the road and you go around rampage and you start to do that? Never thought about it, isn't it? So it's in our own hands as to how you would want to use. So this is how some of the top industry players are looking at human plus machine versus the problem that we have got in hand. Because there are so many problems around the world. As we invent things, as we find out new ways of connecting and collaborating, we are also creating problems along the way, right? I was in Bangkok just about a few weeks ago. So there are all these advertisements where people are like this. So that is their phone and they are like this. Apparently there is a lot of problems developing in your back areas, and there are treatments required because people are nowadays like this, with their mobile phones. So this was never thought of. So with innovation comes problems, and then you have to do again innovations to solve problems. So the idea behind this is human plus machine versus the problem. So AI should support human beings, and technology should always do something to enable people, not to disable people. Some statistics about data. Data is growing at phenomenal rate, and I don't know whether you're sensing it, but I wanted to give you that idea of this. So by 2020, the analysts say that 90% of the cars will be connected cars, and there will be 28 times more sensor enabled devices. And not only that, these devices are going to create data at the rate of 1.7 megabytes of data by every connected human being every second. So imagine 24 hours how much of data is created. In 1 year, how much of data you are going to create individually. So that's phenomenal amount of data. So why did I tell about data? That's because AI thrives on data. The data has to be in the right format so that we can use that for learning purposes. So make the data into the right format and use it to learn. So there are some stages involved in going through this deep learning. That is, let me come back to the basics. That is, if you want to train a computer just like how you would train a human being. If you want to do that, that's the first step. If you want to do that, these are the stages that are involved in order for you to get there. So once you train it, then you think about the accuracy rates, are you able to, so you do some testing and then make sure, okay, this system is ready to launch because it's got the accuracy rate of 90% or so, which means if I show this system a cat and a dog picture, it's able to identify it with 90% accuracy based on what it has learned. So I would have used a lot of data, vast amounts of data, maybe thousands of images of cats and dogs and tigers and lions and so on, elephants and so on, to teach the computer how does a cat look like, how does a dog look like, and from that the computer has learned. So all this is massive amounts of data. So first we have to define the task, how you want to solve the problem. Then you have to prepare the data. So data is in different formats in different ways. You have to prepare the data. Then you will process the data to make sure that it's ready. And then you will select the model, the neural network model that is able to do this identification. Then we have to do the training preparation, then configuring of the hyperparameters in order for you to get the right accuracy rates, and then you do the training, and then you package, and then you deliver it at the edge, so that, let's say for example, using a mobile phone, you will be able to just scan an image and immediately it pops back to tell you, okay, is it a cat or a dog? I'm taking a very simplified example of it, but this is the working of it. So the working of it happens in a second or less than a second. But all the work involved, the preparation work, it could be weeks, it could be months of work, but the identification happened in a split second or less than that. So you can, I hope as academics you can appreciate the amount of work that needs to happen here, and later on when I show you some of the use cases, you will be able to appreciate how much of data that is required and how much of work that goes into each of these stages. Now, from the industry, we have identified at least 3 top challenges. Now, this is where I think your brains can help to solve some of these problems. Maybe you can take some of these as research problems. Maybe you can chip in and help the industry. And it's good for you to know what are the challenges faced in the industry right now. And your solutions, your startups can maybe directly address these cases. So there are 3 D words that you can remember, hopefully. The first one is data. Data itself is a problem. So when we go to clients, customer says, okay, I want to use AI for a particular purpose. I'll give you one example. We work a lot with financial institutions, banks. There's currently a lot being done around credit card fraud detection. There are traditional systems that can already identify, you know, there are these data mining techniques and so on and so forth that are there. They can identify a fraudulent transaction to certain level of accuracy. But you know, people are smarter, you know, the bad people are much smarter and smarter. So what we are now trying to work with industry is using AI on top of the traditional techniques to identify fraudulent transactions. So what the bankers are telling us is, to the IT people, is that if you can improve my accuracy by 0.5%, I can save $10 million. So imagine that. So maybe 50 transaction goes unidentified. If I can use another technology on top of the traditional one, and if I can identify fraudulent transaction accurately, then I will save a lot of money, more money. So that's in the tens of thousands of dollars. So the challenge we have, the data is not in the right format. So we don't just need traditional data, we also need image data, we need social media feed, we need additional feeds coming into the whole system to provide that accuracy rates. Now the data is not in the right amount, or the data is unreachable, or sometimes in some cases the data cannot be accessed because of security and compliance requirements. So these are challenges. The second is something that you definitely can solve, domain expertise. The world is short of data scientists, and it's one of the highly sought after jobs. I think in the US and all, people earn like lots and lots of money. I don't want to tell how much it is, but lots and lots of money. But data scientists are in short. So that is something that you can course correct and maybe do some courses online on your own, learn something on your own, learn about what data science is. And I'm going to give you some tips at the end as to how you can get started. And domain expertise is a challenge. Now we go to client places, customers do not have data scientists. They're just beginning their journey, or it's difficult to hire, or they are in short. And these are some of the typical challenges that industry is facing. Then the third thing is dedication. What I mean by dedication is customers are not able to allocate time and resources to solve a problem using AI. They know that there are benefits, but they are busy with the so-called BAU stuff, which is business as usual. You know, I got to solve my own daily problems, so I can't allocate additional resources to do this. So I don't have time. So sometimes we have had situations, we start some AI projects, customer says, okay, I'm all excited, I want to save millions of dollars or how much ever money that we, you know, kind of go through a business case and identify. They go into weeks and then say, oh no, I don't have time. I got to get busy with my DR exercise, my disaster recovery exercise, annual training. And I got to get busy with audits and so on and so forth. They'll give excuses and the project gets elongated, it takes delays and so on. So dedication is something also is a challenge. So these are 3 top challenges identified in the industry, and if you can find some solutions, that will be great, especially for the startups. So it's a challenge for the startups. Now from here onwards, what I'm going to do is I'm going to tell some stories, some real projects that I have worked on, I have been part of. In some cases I've got to know through colleagues and so on and so forth. So these are projects that we at IBM we have worked, and hopefully this will give you some new insights and maybe derive something that is applicable locally here in Sri Lanka. So you can see, okay, this is how it's been done in this country, predominantly China. I have to be honest with you. China is the hub of all the AI activity, not the United States. China is the hub of all the AI activity, all the IoT, all the robotics related activity. In fact, the largest concentration of researchers for IBM for AI is based in China. So there are lots of researchers and scientists who are based out of China. So let me start off. First one is Bannana Exports. Have you ever thought that we could use AI for banana exports? So there is some initiatives going around. I will generalize these use cases to share with you how they work. For example, take this case of bananas in different stages, if I may say, use the word. So you can see this is almost ripe and ready. Maybe if it reaches a destination, it will go brown or black, or it will go spoiled. So you got to define. You should eat it now or tomorrow, or you can transport it maximum 10 kilometers. But whereas this one, maybe you freeze it and you transport it, maybe it can go distances. So in between, you can decide. So what is being done now is in a large banana plantation where they have millions of banana trees, and they have to do the cultivation and transport this to different places. A country like Australia and all takes a lot of time for banana to reach from one place to the other. They don't grow bananas in Sydney. They don't grow bananas in Melbourne. There is only certain places where there is close to tropical weather, they grow bananas. So it's around Brisbane and areas around that. Queensland, the state of Queensland is popular where there is a lot of banana trees. So for them to transport around the different parts in Australia, they need to classify and identify these. So what's the idea behind this is, so the bananas once cultivated, they go through a conveyor. Now typically, using the traditional methods, what happens is somebody inspects it visually and say, okay, this is good to go all the way to Sydney. This is good to go all the way to whatever the other region or country is, because of the condition that is in. And they want to automate that process to quickly do it much faster, and to meet the production demands and so on. So what they're now doing is, it's actually a pilot project. They're using cameras, and through image identification, they are able to tell, okay, what's the ripe level of it, and based on that, what's the accuracy, and then based on that, the conveyor belt goes into, okay, this can go longer distance, this can go shorter distance, and so on and so forth. They are classified. Now, for this, there has to be a lot of training that has to happen behind the covers, so that it is identified with certain levels of accuracy. Now, I'm telling what happens at the end, but there's a lot of training that has to go on to identify the position of the camera, the identification, and so on. So through analysis, we have found out which country is the most profitable for banana exports. So we started off with about 200 odd countries, and we found out that China is the most profitable country to do business with on banana exports.
Using this type of application,
Yes.
generating training data set is sometimes a little bit harder.
Yes.
What is the effect of manipulating of data to train models?
Very good question. So data, getting the right data could be a challenge sometimes. And one of the things that we are doing in the industry level is what we call the data augmentation. That is, you redo and reshape the data in different formats and lighting levels, and through that we recreate some data to be able to help with the training part. So
Affect the final result?
yes, it will affect the final result. Yes.
Another thing is, when we pre-process data, after pre-processing, for initial data, what can we do? guard them, or we should keep them in?
Okay, so that's another good question. So what do we do with the data that we actually got? So there are certain data that you identified, okay, they are good for training. The rest of it, if you have the storage facility and if you can keep it, it's good, because you may want to train some other use case, other scenario, and it is good to keep that if you have the luxury of the storage facility. So by the way, please do ask questions. I may not be able to answer all the questions because I know some of you are really smart. So if I don't know the answer, I will tell I don't know, and I will get back to you. And I also have my two colleagues here who will be able to help me with answers. If we all don't know, we will get back to you. Or maybe that's something that you can patent it and you can do something interesting with it also. So that's one case. The other case that we are actually piloting right now is bushfire detection. It was actually started about a year ago, but there are some complexities involved in identifying bushfires. Now you may be wondering what this is about, because Sri Lanka is not kind of prone to this type of bushfires. In the US alone, every year there are 60 to 80,000 bushfires that occur. Now there are deaths, there are damage to property, and there is disruption to normal life, and so on and so on, just like what we see in, around the floods these days in Sri Lanka. So just like that, bushfires also can disrupt. Now I live in Singapore. I've been living there for about 6 to 7 years. Now we face something of similar this time, because in Indonesia is a large country, and they do what they call this back burning. That is, they burn the trees and then they use that for plantation. And typically palm oil plantation is the one that really benefits from it. So instead of destroying or properly destroying the old crops and recycling them, the easy way they find is burning the forest. And sometimes it happens in Sri Lanka also. We just burn them and then we do the recycling of the land for another set of cultivation. Now this can actually create a lot of environmental problems, although we are trying to save money. So the owner of the plantation, which may be thousands of acres, he wants to save money because he is going to give, salaries and wages to the people who actually properly destroy it and properly recycle it. So instead of that, he just lights it up and say, okay, let everything get burnt in few days. But that creates smoke and it affects the environment. So the smoke from Indonesia comes all the way to countries like Thailand, comes to Singapore, comes to Malaysia, and all these neighboring countries. And in some days, the pollution levels are as high as 100 times bad. So there are health problems for smaller kids and more seniors in their 60s, 70s, 80s. And this creates a large environmental issue, and in the recent times it has become a serious problem. So we are trying to use artificial intelligence to be able to study this land masses, land patterns, and to be able to predict bushfires before they even occur. Some bushfires are man-made, which means it is created by man, they light it up purposefully. That's the case I explained to you earlier. But bushfires can also occur for various other reasons. Let's say, for example, an earthquake, which causes rocks to move, and that in turn sparks fire, and then plants and greenery get burnt down. It could also happen due to various other reasons. Lightning, for example, in the night, lightning can cause fire, and that in turn. So there are various reasons for that. So we also input weather data into this to be able to predict which location where this can occur. So as you can imagine, this is a very complex process. If plants are more brown, it's dry, and the temperatures are soaring in the 40s, and this typically happens in Australia in the bushfire season, they call it. And during that time, we should be able to predict using this system to sell, okay, there is likelihood of bushfire happening in this area, and that could save a lot of money, that could save the properties, that could also safeguard people's lives, right? And so the research is going on at the moment, and the complexity around it is identifying the weather data to go with, and also the flame patterns, the plantation patterns and so on, which are making it more complex. Weather-based planning and monitoring of plants. I can see some of you smiling, maybe you are familiar with this use case. And this is being actually piloted for palm oil plantation in Malaysia and surrounding regions, where we are trying to make use of drones and taking footage through drones, plus sensors around the plantation. We detect the soil quality, we also detect the fertility levels of the soil and weather patterns and all that, to define how much should we water, which area should be watered. Now, if you have a garden patch of this size, you know where to water what, and you can do it all yourselves. Now, that's your home garden. But if you have garden of the plantation of the size of half of Sri Lanka, then how do you go about managing that? So, you can imagine the enormity of the scenarios in sometimes in palm oil plantations and even tea, coconut plantations, which can be similar in Sri Lanka, which large plantations are there. So, to manage that, artificial intelligence and IoT technologies are being used. In some cases piloted, some cases they are actually in production too. Safety at construction site. Now, the construction sites in Sri Lanka are reasonably small, but recently with the port city development happening, I am sure you can see the enormity and the bigness of such construction sites. They are large construction sites, and probably close to 1,000 or more than 1,000 workers are there, and ensuring that safety is maintained well is important, because I am not sure how it happens in Sri Lanka, but in Singapore, if the vendors break laws, or if there are deaths, or if there are damages, the government imposes a fine, and the fines could be in thousands or millions of dollars. They even impose fines for project delays. So, all this could become very complicated. So, you got to have right mechanisms in place so that you do not encounter those fines, because this can actually result in negative propaganda for the company. Let us say a large company has taken up a massive construction project, and if they encounter challenges, or if they have to pay fines, if their reputation is marred, they may not get the next project. So, I would rather pay, let us say, $1 million to implement a system like this, rather than encountering fines like $10 million or large fines. And as a result of that, I may not get my second project, my third project, my fourth project, because my reputation is marred. So, companies are investing a lot on technologies like this. So, what is the case here is, let us say there are construction sites with thousands of workers, ensuring safety mechanisms can be very complicated. You may be able to install video cameras, but you may not be able to capture all scenarios. There could be scenarios like somebody is injured, so there is some injury, some nails or some dangerous equipment just hanging around. Safety rules are not followed. There is water puddles, and as a result of that, environmental problems like mosquito breeding and dengue happening. And imagine 50,000 workers are working in a construction site, and water puddles, and as a result of that, 50 of them are sick, which is likely to spread to the rest of the 50,000 also, and how much of delay there could be in projects, and how much of fines they would have to encounter or pay. So, all this is interrelated. So, a system is being piloted at the moment in order to ensure safety at construction site, and rules are followed, and in some cases certain workers are not even allowed to go into certain areas of the construction site. Now, to monitor all this, you can imagine with let us say 50,000-60,000 workers at a construction site can be very complicated. So, artificial intelligence based system can help to manage this more efficiently and effectively. The next one is security and surveillance. So, there are scenarios which we encounter around the world nowadays. Some people carrying dangerous equipment, vehicles, and sometimes somebody walking in and shooting with a gun and all that. These have to be real time, monitored, and immediately alerts sent to the authorities, let's say police or security department, so that they could come and take additional action depending on the severity of these cases. So we are piloting some use cases around security and surveillance to be able to effectively identify dangerous equipment. Now you may ask, how are they doing it now? Yes, there are systems now in place, but the efficiency and effectiveness of those use cases or equipment is not sufficient enough to give the security levels, because currently through all these systems things do get by. People do get by and cause damage and create problems, and it is happening around the globe. So a typical system for security and surveillance would look like this, where there's hundreds of cameras mounted, computer terminals, and people have to keep monitoring and so on. What we're trying to do is identifying at real time and reporting it and taking necessary action, and in some cases even predicting what is the possibility of this person doing something dangerous based on the behavior. Now, as you can imagine, these can really get complex. The next one is very interesting case. This has been actually deployed in China. It is about parking management, using artificial intelligence for car parking management. Now, traditional car parks, as we all know, you walk into the car park, so there is the barrier there, then the person opens the door for you, the barrier for you, and you go in, park the car, then you are given a ticket also, then at the end you pay the amount based on how many hours you are parked in that area. That's the traditional way. Now, the city of Guangzhou in China, they decided to use, because that's a fairly modern city, they have lots of video cameras, they wanted to infuse artificial intelligence to be able to charge for parking. So what happens is cameras are monitoring. So you can see here cameras are monitoring, so vehicles are identified, so the number plates have to be identified. So there are multiple cameras coordinating together when a vehicle comes in and when a vehicle goes out, and based on that you can see on that right side it says which of the lots are occupied, which of the lots are idle, and so on, and the billing is done and the person who is parking is automatically charged. They wanted to make use of the existing video cameras, but on top of that they also wanted to use this system to be able to detect other anomalies or abnormalities. Let's say, for example, somebody comes out of the car and pulls a gun, which means is not a normal situation. Maybe he is out there to create some problem. And also vehicle directions. When a car comes, is it going in the right direction? If the vehicle is going in the wrong direction, then maybe there is something wrong. Maybe the person is drunk, or maybe he's not in good mental state, or maybe he's a terrorist. So all this can be detected in addition. So just the traditional parking system, you can imagine how it works, the normal way of working, but it can't detect all these complex scenarios. But on the other side, I also want to tell you that if you want to put such a complex use case into production, that is a working system, you also have to train the system to be able to identify such scenarios, and this can be a complex task. It can take a lot of time. So this particular case, they have started with the parking management, but in the pipeline for future they are also thinking of using this for other scenarios. So you can see how they are thinking futuristically. Okay, we'll get started here with the parking management, because we got the video cameras and we can use some FPGAs to do the detection and logics and so on. This one is about traffic management and monitoring. This is a simple case that we are piloting, whereby which we are identifying what's the type of vehicle that is going through, and based on that be able to make some decisions to maybe define, in some countries you have this road toll system. So depending on which vehicle at what time it passes through, you got to pay accordingly some toll. maybe it's about that, or it's about counting and identifying which vehicles can go through this road and maybe putting some rules and restrictions to curb traffic congestions. So all this has not been defined yet, but we are just doing vehicle counting at the moment. So that's what you're seeing in the video there. What type of vehicle? So it's been identified and doing the counting, and what's the percentage of it is passing through and all that. So maybe you can get your creative juices going now, because in Sri Lanka, at least in Colombo and the cities, we've got massive traffic problems. I am telling you, even in Jaffna, there is traffic problem right now. I went together with Dr. Gamage in December. We spoke at a conference. So there is traffic problems beginning in Jaffna also. And in about a year's time, with the number of vehicles going there, there's going to be problems like what we face along Galle Road. So if you can get your creative juices going and think along these lines to see what you can do about it, and this is the right place you are in, you can come out with some interesting ideas.
I just noticed that in that video, the concrete mixer, the large one was correctly identified, the little smaller one was identified as a truck.
Truck, yes. So that is a very interesting case. So what does that mean? The accuracy is not yet enough. We got to train more data and get the accuracy levels much higher, and so it's a work in progress. So this is of course a pilot.
As a truck.
Truck, yes, yes, Toyota bus. It is ideal to have it 100% accuracy. I have
Due to the issues of parameters, that is hyperparameters and those.
Yes, that's the challenge we have. So
Issue of overfitting.
yes, so it is ideal to have, but we have practical challenges and issues around it. So if you have something that is 90% accurate, it's considered really good, at least with the current technology that we have. This is another interesting case. This is a live project in Korea. So the last time I showed this, I didn't have the video footage of this particular use case being broadcast in the Korean news channel. So we worked actually in Korea with our Korea office. The idea behind here is to make use of artificial intelligence to be able to do transmission tower inspections. I don't have the numbers of how many transmission towers are there in Sri Lanka, but in Korea there are about 44,000 such large transmission towers, tall ones, which carries the main power lines through the country. And Korea is also a complex landscape in the sense, it's got hilly regions, and the weather patterns can vary from things like -27 to all the way very hot periods and so on. So climbing up and doing the maintenance is not the popular job in Korea. So you got to have special skills first of all to be able to climb, and not everybody want to climb this tower when the temperature is like -27 degrees, right? It's tough. So skills are dwindling. People are not going into this type of area. There is a significant amount of risk involved in this because transmission towers can, it can be dangerous. So what we are doing is here, you can see specialized drones are flown closer to these transmission towers, and they take video footage at high speeds, and then they transmit the data to a central office, and there, after the training is done, we locate faults or areas where maintenance is required. Now you can imagine, if this goes rusty and if this falls apart, you need to do it on the right time, and there are 44,000 of them. Plus also all these devices and gadgets, and if you're into electrical engineering, you will know all the details, but they need maintenance too. All this has to be done. So we're using drone footage together with trained data to be able to accurately identify which devices require maintenance at which time periods, and using that for air. Okay, again something similar. There are large solar farms nowadays with thousands of solar panels installed, And if there are issues or damaged solar cells, that means the efficiency is lost and maybe there is some maintenance required and so on. Now, if there are thousands of these, somebody going in and inspecting each one of them is a complicated procedure, requires specialized skills and a lot of time also. So, what we are doing piloting is using artificial intelligence to be able to fly a drone over it, take a high resolution footage and then to be able to identify which ones are the likely faulty ones. So that the engineer, rather than going on looking at the entire stretch, he will know which is the ID that he is supposed to look at. So, it's much faster process and it's much quicker. So, maybe I pause at this time, and I know questions have come from you. So what's your name? Aruna. Okay, so questions have come from Aruna only. I'm sure you are also thinking very seriously. From the looks of it, I can guess you are thinking very seriously. Do you have any questions? All good? Is it useful to you or is it too boring? Are you learning something interesting that you're picking up that's helpful to you? Not for the exam that's coming in 2 weeks' time, of course, because I'm sure you're thinking about that. Yes. Yes.
For training, we acquire a lot of data.
Yes.
So, how do we label them? If it's a massive amount of data, labeling them manually is not efficient.
Yes.
So, how do we face challenge of?
Yes. A very good question. So, those who are familiar with deep learning and neural networks, machine learning, you know that the data preparation is a key task, and I talked about it. So, initially you got to label the data. Now, if you go back a few slides, you can remember we had to do you would have seen, maybe I just go there quickly. Just for the benefit of others, I am trying to just articulate the question that you have asked. So, let me go back. So, if you look at this particular pattern, so let me just go here. All right, okay, thank you. Great, thanks. So, if you look here, we had to do labeling of the data to identify this particular safety hat as well as the safety vest. And similarly, we would be labeling thousands of images like this, and it could take a lot of time. This is a manual task. Somebody has to sit and label all these images, thousands of them, to prepare for training. And his question is, sorry, what's your name? Kavindu. So, Kavindu's question is that, this process would is labor intensive, it's a manual process, how do we manage that? So, from an industry point of view, actually we are tackling this through a process called semi-automated labeling. So, what we do is we label a subset of the data. So, let us say there are 10 million images and all of them need to be labeled. So, what we do is we label part of it, maybe 100 images, and then use that as the base to train the rest of the data, and then do that and then continue that way. So, the idea behind this is it's semi-automated. So, that means you train a small set of data and then use that to train the rest of the data. So, it's deep learning of the deep learning. You kind of use that technique to do that. And
depending on the situation, you can use crowdsourcing also.
You can use crowdsourcing also.
Facebook,
Exactly.
checking, they ask, is this the correct place?
Correct.
That
Yes.
is the crowdsourcing.
Exactly. Yes. Crowdsourcing is another technique that you can use. You get people to actually work for you, although they don't know they are working for you. And in some cases, they tell you that you will be given this much of money if you do this, and they kind of incentivize you so that you work for them. And for some people who are not particularly into this type of job of 5 days and 8 hours a day, they wouldn't mind doing it for 2 hours or 3 hours just to have a little bit of fun. Let us say housewives and so on, they may be interested in doing some sort of thing. So, and there may be other creative ways of doing it also. Yeah, good question. Thank you. So let's move on. So I think I'm over time, isn't it? Another 10 minutes? Can I take another 10 minutes to close it off? Okay. So you have seen a lot of use cases. I'll skip this for in the interest of time. So you have seen some use cases in the industry where we are trying to solve problems. There is efficiency required, there is danger, there is risks involved, and so on. So I have just summarized it as benefits here. You can see some of the benefits. First of all, it improves the accuracy rates. I told you the credit card fraudulent case where we have a traditional system and we are trying to use AI to be able to improve the accuracy levels. Then it decreases time to respond to clients. In the industry that is important. If I don't respond to a client in a particular time, then that client goes to my competition. It happens, isn't it? You go to a website, if it's too slow, you go to an alternate website. Let's say you go to Yahoo to search for something, it's too slow, you go to Google. I mean, that doesn't affect financially both the companies, they are rich anyway, but that's the situation, isn't it? Then it increases productivity and insights, security, safety, and all that, its cases. Then also it decreases the rate of safety risks, like examples of security and surveillance. I shared with you about the transmission tower inspection, which can reduce risks because we are using drones and alternative technologies. So these are some benefits, and of course I am sure you can think of additional benefits also. So I want to just take a few minutes to just talk about key IBM differentiation that are coming through, and I'll just quickly walk you through each one of them. The first differentiation that we have is the server itself. The server itself is designed in such a way to be able to give acceleration. Now the processor speeds are kind of saturated. As a result of that, we are doing acceleration through different other technologies. So they are called, one of them is called the IO or PCIe generation, and then we have a few other technologies. I don't want to go into the details. These are ways of accelerating the compute of this system. Now the Power 9 of course tells you that it's the 9th generation of our power processor. So the processor that we use in our servers is called the power processor. Power actually stands for performance optimized with enhanced risk. So it's not just a power thing. Typically one core of this is equal to about 2 or 2.5 times Intel cores typically. So that's how it's defined. So it's a bit more powerful than the Intel cores. And there are 6 ways of accelerating, and that's something unique in the industry. Then we also have number of cores packed inside. This system is of about this thick. So this how much thickness it would be. So it's called the 2U system, industry standard units, and it's packed with about 40 cores. So if you imagine your computer could be, your laptop could be maybe dual core or 2 cores. So this is like 20 times more powerful, because 1 core is equal to twice. So it's another another doubled times powerful systems, and it can take up to 8 terabytes of storage and 1 terabyte of memory in the system. So it's, and you can have external storage attached to it also. Then the other differentiation that we provide in the technology front is called large model support. Now let me just describe to you what it is about. Nowadays, in order to be able to accurately identify some situations and scenarios, you need much sharper pictures, much more clearer pictures. So we call it higher resolution. So the mobile phone typically takes pictures of about 3000 by 4000 resolution pixels size, and for you to be able to detect a cancer cell, the picture that you take has to be about 1000 times much larger to be able to detect. So you need to store all these images. So the GPU or the graphical processing unit has to store all these images, Now, what we provide is called a large model support. So, typically if your images are this sharp, you can identify more features, versus this one you can't identify much of features. So, if you want to store this much of powerful pictures, more sharper pictures, you need more storage. So, in our large model support technology, what we are doing is, we are using the computer's memory, which is like I told you 1 terabyte, plus the memory in the GPU, which is typically now 16 GB or 32 GB, maximum is 32 GB in each GPU, and typically each of such system can package up to 4 or 8 GPUs, 4, 6 or 8 GPUs. So, when you do the model training in a GPU, the images are kept in the GPU memory only. So, the technology that we have defined uses the main memory of the computer also as the place to store the training images, and therefore brings a lot of efficiency. So, we have done some testings with it with large model support. So, a model testing that took about 3.1 hours could be done in 49 minutes in our server. So, that is the sort of efficiency you are bringing in. And you know, if you have worked on neural networks, deep learning and all that, some of the training tasks could run for days, weeks and so on. Now, you want to do it much faster. From an industry point of view, the value is that you beat the competition. You earn money much more quicker. So, these things matter in the industry point of view. So, that is what this is about, large model support. Then the second differentiation is called distributed deep learning. Now, we start off with one computer when we want to train a model, and typically we sometimes even use gaming computers to start the work. But that is not powerful enough. You know, after sometimes you will find out, okay, I need more computer. So, I need to connect the computers together through a network switch. And when you connect, what happens? The efficiency can be lost along the way as your data gets transmitted and so on. So, what we have done is, we have connected multiple computers to be able to give the best efficiency in the industry. So, when you connect, we make sure that the efficiency is not lost when the nodes are connected together. So, we have tried, I think there is this scenario here, we have tried to connect 64 systems together to reduce the task that took 16 days to 7 hours. So, efficiency is great here. So, you may be thinking, okay, because there were 64 systems, the task got done much faster, but the efficiency and the connectivity also matters, because you do not want to lose a lot of time in connecting it, and that is why the efficiency is important. So, what is the efficiency level? We are able to do that for 256 GPUs, that is about 64 systems, because each system has got about 4 GPUs. We are able to do with 95% scaling, which is near linear almost. So, what that means is it is efficiently utilized effective system. So, this is a unique technology that we have. Then also, let me move on. The third differentiation that we provide is in the way the system is connected. So, let me quickly explain this to you. So, you have the main memory here. These are the chips. These are the 9th generation of the chips. Then you also have the GPUs. So, for each chip there are 2 GPUs attached, and this link between the CPU and the GPU is at 150 gigabytes per second, which is about 4 to 6 times much faster than the traditional what we call the PCIe IO link. So, this is a new a technology that we developed together with NVIDIA. It is called NVLink. It is a proprietary link that speeds up the communication between the GPUs and the CPUs in order to bring greater efficiency. And the fourth differentiation is we have a point and click tool called AI Vision, which is a tool that you can use. I am going to tell you where you can go and you can start your trial and try it out in the cloud and so on. It is It has got this feature called the semi-automated labeling. That's one of your questions. It also got this auto-training capability, which means you don't have to know anything about the neural networks. It provides an encapsulated user interface so that any ordinary person, we actually trialed it with children. Children's primary 1 and 2, in 10 minutes they could develop a model to identify cat versus dogs. So we trialed it in China, in the China Research Lab. Kids came over and tried this out. Then packaging and deploying it into multiple devices, this is at the edge, at the inference level in different devices, is also something that this tool is capable of. So these are the 4 differentiations. I thought I'll share this with you for your knowledge sake, for your interest. So let's move on, and I'm going to actually close off with the last 2 slides. First one is there are 2 ways that IBM actually reaches out to providing AI related solutions. One is called through the IBM Watson. This is the model of buying over the cloud. The models are done, and you can buy the APIs, and you pay per use of these APIs in order to infuse into your use cases. The other one is customers who have got specific scenarios, and in some cases they can't share the data outside of their firewall. In those cases, what we do is we provide this what we call the on-premise solution for clients that is tuned and customized. Now you can see some familiar names here like Cafe, TensorFlow, Torch, Theano, and so on. These are open source frameworks that we have packaged together because we optimized it for the hardware and some of the newer technologies that we are using, and we call it the Power AI software. It is free for you to download and try it out, but the tricky part is it works only on the Power chip, not on the Intel chip. So that's the part. But you can get familiarized with this in the cloud when you actually try it out. So I'm going to propose to you 6 ways of getting started if you have interest. I think some of you showed interest, at least you asked questions, so I'm imagining you are interested. First one is you can test drive this software and build some models, try it out. So this is the link. I will send this to Dr. Sulochana later on, and you can distribute it to the guys if they want to try it out. The other one is you can read some free books in some of the technologies. So you can go to this link called redbooks.ibm.com, and there are PDF copies of the book that you can download to learn some of the technologies as to how they work and so on. These are free books. You can just download them, you can use them, and you can share with your friends also. So there are books around the Watson technology, there are books around the Power AI technology you can use. Then there is an opportunity for you to learn. If you are totally new to this is the first time you're hearing about neural networks and deep learning and machine learning, you can go to this website, and there are plenty of others also. I'm just telling this because this was developed by one of my colleagues, and this is a free website where you can just go register and learn some of the newer technologies, cognitiveclass.ai, and there's no fee involved in any of these. You just become a member, register, and then you start to try it out. Then you can also be part of some of the meetup groups. Meetup groups are like a special interest groups where people come and give talks and so on. Some of these are broadcasted over the website also. So if you are interested in our meetup group, you can just register here and you can be part of it, and you can listen to the talks being located in Sri Lanka, or you can come over to Singapore and you can spend some time with us when we do the sessions. And of course you can connect with me via email if you like, and that's my contact number if you want to talk about any of these technologies that I discussed today. So with that, let me say thank you for listening to me. Thank you for your questions. Are there any more questions? Yes.
Correct. So is there a way to change that to say, rather than using just pixels,
likewise, could you like store the training set as a set of differences or anomalies rather than like computer pixels?
Okay. So let me just try to understand your question. Your question is, let's take the example of Mona Lisa. Maybe there are fake pictures also around. How do you identify the authentic one? You know, that's the question in summary, isn't it? Yes. So that's the question in summary. How do you identify the differences in such complex scenarios? Because they both look alike the same in an image or in a video. How can you identify which is correct?
More specifically, like, is there a way of storing the data, like when you're storing and using the model, like the training set, is there a way of storing the training set as like differences between the images rather than as actual like a grid of pixels?
Okay. So, in the way of storage, is there any specific scenarios where you can find some unique cases? So, the answer to that is I don't know. I'm going to check this. There could be some new technology. From what I know, I haven't heard of anything unless Dr. Gamage or anybody knows about this new technologies.
Full detection is done by studying a series of paintings by a particular artist, say Van Gogh. So he has a particular way of say brush strokes and particular way of marking the artwork artist does. So of course the forgers also try to do an exact reproduction. So we are talking about, okay, we have been clear about what people know. So a forged masterpiece is actually another drawing. It's not a photo like this. So I don't know whether we are talking the same thing. So like say Mona Lisa is there, and you can have like a trillion Mona Lisas digital.
Yes,
They are all original.
exactly.
If there is an original Mona Lisa digital, all the other trillion copies are also original. We are not talking about that hopefully. We are talking about an original Mona Lisa, hand drawn, and another Mona Lisa which is also hand drawn, and now you won't know which one's
The accurate one.
the original. So that the brush strokes are what's usually
The possible,
specialist.
right. Yeah. So, so your question is a very good question because there are still technologies that are evolving to identify such complex scenarios, complex situations. Because AI is not the answer for every situations. That's where I think customers are now, from an industry point of view, customers are now trying to figure out which is the most effective way I can use AI so that I can earn more money. You know, it's about being efficient, being profitable in the marketplace, because competition, not just in IT or in the academia, everywhere there is competition that's tightening up, and there is serious competition. So, because of that, there is innovation also that is, you know, fueling all this and finding out solutions to this, but not all answers are found.
Yeah, but there I think there's like a real like application to what he was referring, like this image that is Getty image, for example.
Yes.
They license the image, and some people get the license image and modify it slightly, so it will like if you do a hash and with a hash it won't match. But they are using AI to check whether it is a altered image,
Yeah.
which is violating copyright.
Copyrights, yeah.
In that sense, it could be the bits that are getting stored.
Okay, any more questions? Yes.
In current AI technologies, people are trying to simulate the brain, human brain. In AI technologies, people are trying to simulate the human brain.
Human brain, yes.
So, is there any inherent hardware problems when doing that other than software problems, and are you working on such scenarios?
Okay, that's another good question. So, The AI is about simulating the human brain, how it thinks, understands, reasons, learns and all that. What are the challenges in the hardware? So, I touched on a few of those challenges that the industry is facing now. One of them is, of course, the acceleration capability, because the silicon has reached its maximum potential threshold. Just increasing the clock speed of the CPUs won't just help, and that's why we are in fact quite a few vendors are doing it, and we have kind of led the market by doing acceleration through different means, like for example accessing the computer's memory direct rather than going through the IO. So that is an acceleration method, so that we can do it faster. Now there are also data center technologies that are maturing and providing answers to that, because GPUs generate a lot of sound and heat. They are massively parallel, but they also generate a lot of sound and heat, noise and heat I should say. And the problem with that is data center has to be energy efficient, and to manage that we are working on some of the technologies around that. So these are some of the areas that we are working on: acceleration, chip acceleration, and that's why I talked about the OpenPOWER Foundation in the beginning, where we bring in vendors from multiple disciplines, like Mellanox on the networking technology, Google in the search and other capabilities like image processing and all that, then IBM, then Samsung, then there are multiple vendors coming together to collaborate together to provide answers to that. And the most recent one that I have seen from my company, from IBM, is that traffic. We've just launched some patents around traffic management, so that traffic is effectively managed using AI. So some of the AI patents have come through with that. So that's more on the software side. And also we developed this tool called AI Vision, which is more easy to use and accessible to anybody, so that easily people can learn. You don't have to be a data scientist to be able to use it. So that is to mitigate the skill challenge, skill shortages.
Are there any related problems? I heard that there is an inherent architectural problem in hardware to stimulate the human brain.
Okay, so that problem is existed right throughout, because the machines are machines, and we are kind of trying to simulate and provide the capability to be able to. So massive processing is one of the challenges that we have, because of the amount of data that goes in there, and the related problems such as heat and all that. And if you're asking in the architecture itself, I do not know about that. Architecture itself, I don't know. I have not gone into that. So my role actually goes around more solving client problems with the existing technologies. Research is something that I sometimes coordinate with some of the collaborators who are working on it, and maybe if you connect with me, then I can put you in touch with some of the people who are working on the much more cutting edge stuff than me. Yeah. So that is our research organization. So we call it the IBM Research. So there are researchers dedicated looking into these particular problems. So your question is more probably related to that. But the traditional way of solving some of the practical challenges now is this way. Thanks. Thank you very much. I don't know, is somebody going to close the session, or that's it? Okay, that's it. Thank you very much. All the best with your exams. I think your exams are coming in 2 weeks. And keep in touch, and I think through this OpenPOWER collaboration, we will provide more lectures and interactions, and hopefully I'll get to meet you again the next time I visit Sri Lanka, and we can talk about something else, and keep in touch. Thank you. Bye.
Thanks, Gerard. Maybe most of you don't know that there's Intelligence Lab. We became a member, academic member in OpenPOWER Foundation, and I'll be the contact person. If you have any queries, if you have any things to organize or in collaboration with IBM OpenPOWER, please contact me so I can.
Yes.
great
So there are about 80 to 90 universities around the globe that are part of this organization called OpenPOWER to fuel research and collaboratory activities. So you have become one of the universities to be part of that OpenPOWER, the foundation, which is spearheading some of the research initiatives and collaboration with the industry. So that's what this is about, and hopefully we can benefit from each other in sharing technology and ideas and initiatives around it. So that's the whole plan. You can actually go to the link openpower.org and you can learn a little bit more about what this foundation is about and what we are trying to do. Some of you got startup ideas, you can start up companies, and you can start your ideas using some of the technologies that are there. Thank you.
On behalf of
Correct. Yeah, go to it. But you have to make sure that that happens also.
Otherwise the department.
Yeah, that's right.
okay.
Hello, good morning everyone. So today we have Mr. Gerad as our guest speaker. So he will be talking about industry directions including AI, ease and agility. I warmly welcome him to talk about his experience and share the use cases in the industry and all. So let me give you a brief introduction about him. He's a technical sales executive Asia Pacific at IBM, and he currently works at IBM in Singapore. He has 16 years of working career in IT. He has worked in Sri Lanka, Singapore, and Australia as well. He has obtained his bachelor's degree in computer science from India, and he has completed his master's in the field of information management at Bannana Exports Training. And he also displays interest in usability design, cognitive computing, cricket, photography, and teaching children as well. So I'd like to invite you to start the session.
Okay, thank you. Thanks for the introduction, and thank you all for making it. So I think I will take the next 1 hour or so to share some of my experience. I come from the industry, and you of course are studying some of these subjects and you are trialing it, so your brains are fresh and you'll have even greater ideas. So the idea behind this session is share the industry point of view and also learn from you what you guys are doing, and based on that maybe we can strike some collaborations going forward. Maybe you've got some ideas and so on. And as we all know, artificial intelligence is not something that is new. It has evolved over the time, and it's been around for more than 60 years, to be honest. So the term AI was coined about 60 years ago, so there's nothing new about it. But somehow things have come together in the recent times. And I'm also here actually for a specific reason. That is because of this foundation called OpenPOWER Foundation. So I of course work for IBM, and IBM is one of the founding members of this particular foundation called OpenPOWER Foundation. And what we decided was that technology is being opened up greatly. There are a lot of open source and open technology initiatives happening in the recent times, and we thought maybe we should bring some partners together and work with them in their own areas of expertise, and as a result of that, these culminating together will result in better technologies. So that was the whole idea behind this. So we partnered with companies like Google, Micron, of course in the chip industry, NVIDIA, of course, if you are into gaming, you know who they are, and Red Hat and Ubuntu, of course, the Unix partner. So the rest of them are familiar names to you too, like Hitachi and Mellanox and so on, and you might have also heard of Samsung and so on. So these are all mobile world, and you will have mobile phones from some of these vendors too. So we formed this consortium, which is called the OpenPOWER Foundation, centered around some of our chip technologies in order to enhance and collaborate together to bring in best in the technology. And in today's talk, I will cover about 4 different aspects in the next 45 to 50 minutes or so. I'll first introduce to you the world of digital intelligence, and then we'll move on to some of the challenges and how we are mapping these challenges to some of the use cases and getting back with some of the interesting deployments in industry. Then also we'll talk about some of the technologies specific to IBM and how you can get started today, because at the end of the day you're learning something, you want to put that into practice, and how you can get started today. Now through all this section, I want you to think and innovate and come out with some creative ideas, because bulk of my presentation is going to be around some of the theories that have been put into practice, and some of the customers who are already starting to either pilot or already starting to use some of these technologies. So maybe you'll have some interesting ideas to solve problems around you. You don't have to go that far. Solve problems around you in simple, interesting, creative ways without, if I may use the word, complaining. You know, we are all good at complaining. And I've lived in Singapore for nearly 6-7 years, and the Singaporeans there think they are best at complaining. And I tell them, as human beings, we are all complaining, because the moment you kind of used to something and the advantages of it, then you say, okay, I want something better. I want something even better. I can't wait for this bus. I want it much faster. So maybe we can think through and find something interesting to come through. Okay, this is moving really fast. I don't know why. Something didn't work right. So let me just go back. I think there is some problem with the connectivity. Okay, let me see. This will help. Okay, now it's good. So, as human beings, there are certain things that we are really, really good at. That is, we can understand, we can reason, and we can learn things. And that is what we have been doing from our childhood days. I hope you will remember your beginning days where your mom or dad called you and showed you what a cat looks like, what a dog looks like, and then you will look at a cat and say it's a dog, and then you look at a dog and it say it's a cat, and then your parents will correct, and you will start to learn fast. And do you know that when you're a child, you take pictures in your brain at speeds phenomenally, and by the time you're like 3 years old, you have mentally and using your brains, you have taken millions of pictures. And that is your beginning, and you learn very, very fast. And human beings, we are good at understanding, reasoning, and learning. But the challenge is also we forget as we grow older. You're still young, but we forget, and you get tired, and we are not fast enough to keep up with the pace. And that is where there is this new phenomenon called artificial intelligence that is coming forward, where intelligence is artificially created and infused into various technologies, so that you don't forget, you don't get tired, and you're fast, you're quickly doing stuff. And as